Hai, Assalamualaikum, selamat sejahtera. Hari ini kita nak bincang Zero to Hero Challenge untuk topik thermochemistry. Okey, untuk soalan pertama, cuba kita tengok soalan pertama. Experimentally determine values standard enthalpy change of combustion for benzene, carbon and hydrogen were found to be -3280. It's for benzene. This one is for benzene. And then 393 carbon and hydrogen is 286 respectively. Using this value, calculate standard enthalpy formation for the benzene. Okay, so now we need to find the standard enthalpy formation for the formation of benzene. Therefore, we need to construct our equation. For the formation of benzene, according to definition of enthalpy formation, that is when 1 mole of compound form from its element. The element required to construct benzene is carbon, solid, and hydrogen gas. Therefore, we must make sure 1 mole compound form at the right side. Therefore, we need to balance. To produce 1 benzene, we need 1 mole of carbon and 3 mole of hydrogen gas. So, this is the thermochemical equation for the enthalpy of formation benzene. Therefore, we need to find the enthalpy formation of benzene. And then given the enthalpy change for combustion of benzene, carbon and hydrogen is respectively given. Therefore, we need to construct their thermochemical equation for each combustion of these compounds. Right. For the combustion of benzene, we are going to burn benzene in excess oxygen and producing carbon dioxide and H2O. Okay. According to definition of enthalpy combustion, that is 1 mole of compound burned in excess oxygen. So any organic compound that is burned will form carbon dioxide and water. Okay, so here we must make sure that 1 mole compound form. For the combustion of carbon, we try to construct its thermochemical equation for the combustion of carbon, where it is combusted in oxygen and producing CO2 and CO2 only. Okay, that is the value of enthalpy change for combustion carbon, while hydrogen combusted in oxygen and producing water. That is the energy. Okay, so sekarang berbalik kepada apa yang kita nak cari. Kita nak cari enthalpy formation for this one. So we are going to use algebraic method, or we are applying Hess's law to find this enthalpy change when we have 3 thermochemical equation. Right. So this is our we call it as what? Our target equation. This is our target equation. After we write down our target equation correctly, we need to use the equation given, not given, the equation that we have construct, and then we are applying into algebraic method. Okay, first one, kalau kita nak carbon dekat sebelah kanan and benzene kat sebelah kiri, sebelah kanan, carbon sebelah kiri, kita tengok equation, kita nak benzene di sebelah kanan. So kita cari daripada equation ni mana benzene. Equation yang ada benzene adalah equation yang pertama, Tetapi equation ni benzene duduk sebelah kiri. Sekarang kita kena convert equation, reverse the first equation so that benzene located at the right side. Okay. So sekarang kita convert, kita dapat benzene di sebelah kanan. Okay, the first equation. So since kalau kita gunakan benzene ni sebelah kiri, dia adalah negatif 3280. Sekarang kita dah reverse, so dia akan jadi positif 3280. Untuk equation seterusnya adalah kita nak make sure that we have carbon and hydrogen at the left side. So we just take the second and third equation and remain at the left side. Okay, carbon. But for carbon we need 6. So the second equation must multiply by 6 and the enthalpy also multiply by 6. Okay, so enthalpy also multiply by 6. Same goes to hydrogen. We need 3 hydrogen. Therefore, we take the third equation without reverse. Just multiply by 3. The whole equation multiply by 3. And the enthalpy also multiply by 3. Okay, and then kalau kita nak tengok betul tak apa yang kita buat, cuba kita highlight our target equation. We need 6 carbon, and then we need 3 hydrogen, and we also need 1 mole C6H6. The rest we need to cancel. So let cancel 6 CO2 at the left side, cancel by 6 CO2 right side. 3 H2O left side, cancel by 3 H2O right side. Okay, next is 6 oxygen sebelah kiri tambah 3/2. 3/2 is 7.5, right? 7.5. So 15/2 is 7.5 oxygen. So 7.5 oxygen left side, cancel by 7.5 oxygen right side. Therefore, bila kita dah berjaya cancelkan unnecessary item and we already get our target equation, so we rewrite the whole equation and then we just summarize all this enthalpy for each of the equation. Therefore, we will get delta H1 to 3. So it's equal to this one. So it's equal to 64 kilojoule. Okay. So dekat sini enthalpy formation yang kita nak cari di sini adalah enthalpy formation of benzene. Therefore we will get enthalpy formation of benzene is positive 64 kilojoule per mole. Okay. So positive 64 kilojoule per mole. Sekarang kita pergi ke soalan yang kedua. Quantity of 6 ml of 0.3 molar barium hydroxide mixed with 60 ml of HCl. So ini base, ini acid. Okay. So kita tahulah reaction dia adalah acid dengan base, which is neutralization. And then place in constant pressure calorimeter of negligible heat capacity. So tak ada heat capacity dekat sini. And the initial temperature both solution are 22.21. So respectively their temperature is 22.1 and calculate the final temperature of the solution. So when we mix together this solution, what are the final concentration? Okay, so given from the question, let us extract the information from the question, which is the heat neutralization given is negative 56.2 kilojoule per mole. That means for 1 mole of water formed during the neutralization, heat release is 56.2 kilojoule. And the capacity, specific heat capacity for the solution is 4.18 and the solution is density 1 gram per mil. Okay, first of all we need to find what is the number of mole for barium hydroxide and mole in the HCl. Okay, by using formula M1 MV over 1000, we can find the mole of barium hydroxide. Okay, so 0.0204 mole barium hydroxide, while 0.0408 mole of HCl. Okay, then we construct the equation. Barium hydroxide react with HCl and producing barium chloride as a salt and water. Right, from the equation, 1 mole of barium hydroxide will react with 2 mole of HCl. Okay, sekarang kita nak tahu berapa mole water form. But since the mole of HCl and barium hydroxide tak sama, kita kena cari limiting reactant dululah. Okay, so 1 mole of 0.024 mole of barium hydroxide will require 0.0408 mole of HCl. So the mole of HCl will be equal to the mole of water. Sekarang kita tengok siapa yang dekat sini. Daripada equation, kita buat ratio reactant to reactant untuk cari limiting reactant. Okay, sebab kita nak tahu mole of water is depend on mole of HCl atau depends on mole of barium hydroxide. So kat sini kita tengok kalau kita tindak balaskan ke semua barium hydroxide ni, mole of HCl yang diperlukan adalah 0.04 dan kita memang ada 0.04 mole. Maksudnya at the end of the neutralization, sebanyak 0.024 mole barium hydroxide habis digunakan dan HCl pun habis digunakan. So amount of HCl, amount of water is depends on the number of mole of HCl. Sebab apa? Cuba kita tengok kat sini. 2 mole of H2O depends on 2 mole of HCl. Okay, so kalau nak kata sama dengan ni pun betul juga. Sebab both base dan acid habis digunakan. Okay, so since kita ambil yang ni dah senang, 2 mole HCl produce 2 mole water. So mole HCl sama dengan mole water. So mole water adalah 0.0408 mole. And given the heat of neutralization is negative 56.2 kilojoule. So 1 mole water form melibatkan 56.2 kilojoule. So sekarang kita nak cari kalau 0.0408 mole water form, the heat produced is negative 2.2930 kilojoule. Okay, therefore heat released by the reaction is heat absorbed by the solution. So sekarang kita nak kira lah, heat absorbed by the solution is MC delta T. Okay, formula dia. And then the heat of reaction daripada yang kita kira tadi is 22930. Kita convertkan kepada joule, substitute dalam MC delta T ni. 120 is dia punya mass tadi 60 ml, 60 ml, so 120 ml. Density dia 1 gram per liter. So total mixture of solution is 120 ml is equal to 120 gram. So ini 120 gram times specific heat capacity times temperature change. Okay, so kita nak cari temperature change, dia adalah 4.87. So dia kata the final temperature of the solution. Okay, macam mana nak cari final temperature of the solution? Initial temperature dia adalah 22.41. So bila kita campurkan heat release heat is absorbed by the solution. So maksudnya bila solution tu absorb heat, temperature dia akan bertambah lah, daripada 22.21 bertambah sebanyak 4.57. So final temperature dia adalah 26.78. Next, soalan 3. A bomb calorimeter is used to measure the heat combustion 0.64 gram of organic compound. With the molar mass 1 to 8 gram, the temperature of the calorimeter and content is increased by 2.54 degrees Celsius. So temperature dia bertambah selepas tindak balas berlaku, and the heat capacity of the calorimeter is given 10.13 kJ per degree Celsius. Calculate standard enthalpy of combustion. So dekat sini cuba kita bayangkan 0.64 gram ni duduk dalam calorimeter compound X. So dia sebanyak 0.64 gram. So bila dia terbakar, dia akan release heat heat released by the combustion is absorbed by the calorimeter. Okay, so ada tak dia mention dekat sini absorbed by water? So dia tak bagi tahulah. Maksudnya kandungan heat tu berada di dalam calorimeter. So kita boleh kira lah berapakah tenaga yang dibebaskan daripada pembakaran. Okay, so heat released by the reaction is absorbed by the calorimeter sahaja. Okay, based on this one kan. Then macam mana kita nak cari calculate the enthalpy of solution X? So first kita kena tengok reaction is formula dia kalau absorbed by calorimeter is C delta T. So masukkan dalam formula C delta T, the temperature change is 2.54, and then dia punya heat capacity calorimeter 10 kJ per degree Celsius. So finally heat of reaction is 25.7302. Maksudnya bila kita bakar 0.64 gram ni, tenaga yang dibebaskan daripada pembakaran tu diserap oleh calorimeter, dan calorimeter menyerap tenaga daripada pembakaran tu sebanyak 25.73. So ataupun tenaga daripada pembakaran 0.64 gram tu, dia akan membebaskan tenaga sebanyak 25.7302. Tapi sekarang soalan tanya calculate the standard enthalpy combustion X. According to the definition, okay, pembakaran, heat of pembakaran adalah apabila 1 mol compound terbakar. So kita tak tahu 0.64 gram ni is how many mole. Therefore we need to find the number of mole of compound X. So 0.68 divide by the molar mass of amount of X. 0.68 0.64 lah. Okay, 0.64 kat sini. So the number of mole is 5 exponent negative 3. So sebenarnya daripada tindak balas kita telah membakar sebanyak 5 eksponen negatif 3 mol X, dan kalau terbakar sebanyak ni, heat yang dibebaskan adalah 25.73. Jadi kita nak cari heat of combustion. Heat of combustion adalah apabila 1 mol bahan terbakar. Jadi kalau 1 mol bahan terbakar, kita buat ratio cross multiply, you akan dapat sebanyak 5146 kJ. So heat of combustion adalah untuk 1 mol adalah sebanyak 5146.04 kJ per mol, dan dia adalah negatif disebabkan pembakaran. Okay. And the last one, kita pergi ke soalan 4. Menggunakan data ni, Born-Haber cycle for potassium bromide, determine lattice energy. Okay, kita ada atomization potassium, energy ionization potassium, atomization bromine, affinity bromine, enthalpy formation. So kita nak apply fa'il. Bila kita nak buat bond Haber, remember we are doing fa'il. Buat dulu formation and then buat lattice, barulah diikuti dengan atomization, ionization energy and electron affinity. Okay. Ni fail ni. Ionization energy, electron affinity, baru lattice. Tapi kita mesti buat dulu formation dengan betul dan buat lattice energy equation dengan betul. Okey, sekarang kita nak buat apa? Potassium bromide. Potassium bromide. What is the formula of potassium bromide? It is KBr. Okay, next is mana? Okay, potassium bromide. The formula is KBr. How to form? That is 1 mole compound form. That means we need to maintain 1 mole of KBr form. It is formed from 1 mole of K, and then this one Br 1. So kat sini Br 2 setengah. Okay, formed from its element. So the KBr is formed from potassium and Br2. Okay, element dia adalah Br2, not Br. Tapi kat sini bila kita nak balance supaya kita maintainkan dia 1 mole, so 1K and then Br kat sini 1, half Br2. So we have done our enthalpy of formation. Okay, so here we are labeling our enthalpy of formation is given negative 393.8. Okay. Okay, next. So bila kita dah buat formation, kita buat lattice pula. Okay, formation done and then lattice. Okay, how to make lattice? Lattice is the ion, gaseous ion that form ionic gas. Okay, maksudnya dia dekat sini ion. Macam mana kita nak form KBr from its ion? So it's from K plus and Br minus. So just pecahkan KBr ni kepada K plus and Br minus. So kita nak form this one, it's from gaseous ion. K plus ada 1 mole and Br minus 1 mole. Okay, therefore this equation is referring to the lattice energy yang kita nak cari. Sebab soalan minta lattice kan. Okay, setelah buat lattice, kita boleh buat atomization. Okay, selesaikan satu-satu part dulu, metal. And then atomization by non-metal. Okay, untuk ionization, it's for metal. Okay, kita ionizekan dulu, atomize dulu solid potassium to solid to gas potassium. Okay, so the energy of enthalpy atomization of potassium is 89.2. After forming the gases, we can convert to ionize. So dekat sini adalah ionization energy, iaitu removing of 1 mole electron from 1 mole gases potassium. Okay, the energy required is 419. Okay, so we have done the metal part. Now we move to the non-metal part, which is bromine. So kita nak form bromide. So bromide datangnya daripada bromine gas. Br2, 2 Br ni. Okay, Br2 is like this, Br bond Br. Sekarang according to definition of atomization is the energy required to form 1 mole atom. So sekarang kita nak form 1 mole atom bromine. So dekat sini setengah Br, kat sini setengah Br2, dekat sini kita nak form 1 mole Br. Therefore we don't need to multiply with anything. We just put the enthalpy atomization for bromine. Maksudnya untuk form satu bromin ini perlukan sebanyak 119. So sekarang setengah ni sebab kita nak maintain dekat sini 1. How do we know we need one bromine gas atom? Because here we need 1 mole Br minus. Okay. Daripada Br gas atom, kita boleh tukarkan dia kepada Br minus, iaitu electron affinity. Gain 1 mole electron will release heat negative 24.6. Okay, so we have done our metal part and our non-metal part. Kita dah buat semua ni. Okay, next is kita nak cari this one. So we are using this root. Okay, so our root is this is our starting point. Okay, starting point. We'll start here and you will go and reach here. That is your end point. Your end point is the KBr, at the KBr. Alright, so the alternative route is from the same starting point, and then we go here and going up. Okay, therefore our first route, this route, will equal to the energy of the alternative route. So to have alternative route, this route equal to delta H2 plus delta H4, 3, 5, and 6. Therefore, delta H1 equal to the total energy of the alternative route. So ini adalah Hess's law. Ni single step equal to the energy of multiple step. Okay, so kita boleh cari delta H6 kita is equal to, substitute everything, and finally you are going to get negative 689.3 kilojoule untuk delta H6 ni. So delta H6 ni adalah lattice energy. So tukarkan dalam bentuk yang standard is negative 689.3 kilojoule per mole. Okay, itu saja, dan kita akan bersambung nanti